Assalamualaikum and good afternoon. I greet to our fellow audience and respect the panels. We are from Group 2 of Science Project January semester 2022. We'll be presenting about geomorphology analysis and potential solution to major flood in Hulu Langat, Selangor. Our group is supervised by Dr. Abdul Halim Abdul Latif and co-supervised by Mr. Amnor Amin Zakaria. Next, introducing the members. I am Nur Hadir Ramit Abdulaziz. I am the group leader of this project. Next, we have Mariam Nur Khalisa binti Nur Hamdi. Next, we have Muhammad Shazwan bin Sabri. And lastly, we do have Nur Hakimi bin Ruslan. Here is a table of contents of throughout our presentation. Firstly, we'll be having our problem statements. We're presenting also our objective, methodology, geomorphology analysis, designing of our final simulation, result and discussion, economic consideration, and also conclusion. Task has been distributed fairly between the members. Thus, all of the members are in charge of the design final artificial limit simulation, finalizing the budget of the project simulation according to our economic consideration, execute the build-up of DB simulation together. And as a group leader, I'm in charge of the project planning, such as task location, methodology, and also Gantt chart. Mohammed Shazwan is in charge of research for design concept of possible solution and justification of final concept. Mariana Kalisa is in charge of the geomorphology analysis of the problem and literature review. And lastly, Muhammad Hakimi is in charge of the calculation and discussion of the final result of the simulation. Our proposal statement includes understanding the geomorphological analysis of the area to identify the origin of the major flood in Hulu Langat, and thus coming with the proposing a solution to mitigate a major flood in Hulu Langat. And lastly, introducing a feasible method to decrease casualties of the area which is suitable with the terrain and cost effective. With that, we have come up with three main objectives as a focus for our project. Firstly, is to understand the geomorphological structure of Hulu Langat by its stratigraphy, soil content, erosion, and also hydrology. Second is to lessen casualties affected at high-risk area nearby Langat River. And lastly is to propose a possible method with minimum cost to reduce the amount of flash flood. Making sure that our project will run successfully, we come up with a methodology which started with problem identification and data analysis, physical simulation designing, physical simulation build-up of our artificial EV, and lastly, it involved with physical simulation testing and result of our artificial EV. This testing will make sure and prove that our artificial EV can be used as the possible solution for the flash flood that happens in Hulu Langat. Next, I will pass to Mariam.
For the Hulu Langat geomorphological analysis, we focus on the features and the structure that form the area surface and how they impact the major flood. So Hulu Langat is a district Selangor located in the shown latitude and longitude. Here we attach a map, a Google Map figure shows the geography of Hulu Langat, and at the bottom picture we created a simple model using a basic geological mapping technique application. Both of these figures reveals that the region is surrounded by ranges of mountains. So on the right side picture we attach a main channel that impacts the hydrology of Hulu Langat, which is the Langat River. So the Langat River basin can be divided into three parts: upstream, midstream, and also the downstream according to the color. So Hulu Langat is located upstream of the river basin, which is the yellow color, where the riverbed is steep and water flowing at high velocity. In 2017, Abin et al. Performed a study on the Langat River basin, finding that clay dominates the region in the river basin. So erosion tends to happen in area dominated by clay because the rock has a high response of reactivity due to the surface area to volume ratio. They also discovered several types of erosion, including sheet, reel, and gully type erosion. So this erosion have the potential to pollute the Langat River water with silt and chemical residue that have precipitated and accumulated in the river, where it also has the ability to change the flow of the waterway's direction and vitality. As a result, if Hulu Langat overflows, it will flood other nearby areas. According to 2070 case study by Saudi et al., the Langat River is controlled by monsoon equatorial conditions, with the climate of the river basin being uniform and feverish. Their rainfall and humidity are also controlled by two monsoon seasons, which are the wet season from April to November and the dry season from January to March. This has an impact on Hulu Langat's hydrology and geomorphology, which explains why the area is hot and humid all year and also become prone to soil erosion. Hulu Langat was also subjected to the southwest monsoon, which occurred throughout their rainy seasons that made the river overflowed, causing the floods. And the flooding occurs mostly after rains, when the fresh runoff erodes primary layer that build throughout the hot and humid season, then flush them out to the river where sedimentation and accumulation occur. As a result, the downstream area becomes shallower and turns the water milky, that contributes to the December flood disaster. In terms of Hulu Langat urbanization, it has switched from the agriculture to the industrial sector. Due to the unusual industrial activity such as the EKVE project, the population has grown, resulting in a higher rate of discharge from population area, leading to the severe sedimentation near the Langat River, which is now overflowing with domestic waste. Hence, the major flood last December brought garbage and wood piles to the affected area.
And I will be talking about the design method. So our chosen design method is to implement levees at the Langat River such as levee armoring and levee cut-off wall. By implementing artificial levee, we can improvise the existing levee. Levee is used to keep the water in the river from overflowing its banks. We can also prevent strong water current from washing into undesired banks. There are two types of levees, which are natural levee and artificial levee. In this project, artificial levee is the most preferable choice. So you guys must be wondering why. Why is it so important to improvise the levee? So firstly, the surface area can be altered to make it more stable. Secondly, the slope can be increased to provide a better support. And lastly, the strength of the levee can be increased as we use better foundation material to make the levee. So most people must be wondering what are the ways on how to improvise the levee. Well, the first way to improvise the levee is by using levee armoring, as it can make the levee less vulnerable to erosion. We use three types of materials, which are concrete, high density polyethylene mesh, and turf reinforcement mats. Briefly, these three materials have high resistance towards cracking, as it can withstand high pressure exerted on it. Um, so levee armoring is very suitable for flash flood events where the water travels in a very high pressure. Next is the levee cut-off walls. The reason why we apply this is to prevent the groundwater from entering more into the internal part of the levee. If lots of water enter the internal part, it will somehow increase the uplift pressure beneath the levee, which may lead to the levee being collapsed. Cut-off walls are made of the mixture of cement and bentonite are placed in the middle of the levee. The mixture will act as a barrier as both materials have low permeability towards water. So in this slide, this is our proposed structure of the levee. The base of the levee should be triple the height to provide a greater stability of the levee depending on the water level during the flood in that one particular area. The cut-off walls are placed in the center of the levee and it penetrates down to 37 meters and has a thickness of 1.8 meter. On the side and top of the levee are covered with high-density polyethylene mats and turf reinforcement mats. As for the third layer, and also acting as the most external layer, it is covered with cement to give a more support to withstand the pressure.
As this slide shows the result and discussion part, we want to show the difference of both levees before being left in the water and after being in water for 3 days. There is not much difference in physical changes in both levees. However, natural levee seems to show some obvious observations. Its texture becomes spongy and more watery as it absorbs the water, which show in water level declination from 2.5 cm to 2.0 cm. This 0.5 cm inclination shows that 400 centimeter cubic volume of water has been absorbed into the natural levee, which shows that more volume of water absorbed compared to the artificial levee. It was measured that there was a slight drop in water level in artificial levee, which is 0.1 centimeter or equals to 40 centimeter cubic volume. Both levee shows it has absorption characteristics, but since both of the material used has pores, which is the clay soil for the natural levee and cement for the artificial levee. What makes it different is the size of the pores, which the clay soil has the size of 0.01 micrometer, which is it's bigger than cement, which is 16 nanometer to 25 nanometer. The large pores allow more water to diffuse in, thus make the soil become more watery than cement. After measuring the levee in 3 dimensions, it was calculated that the natural levee has been damaged for around 40%, which 652.964 centimeter cubic has been destroyed from 1,632.41 centimeter cubic. Meanwhile, in artificial levee, no damage was observed. Moving on to the economy in consideration part, this is the overall budget allocated to run this project. There were several new items have been added into the budget list, and the overall totals for the budget differs a bit from the proposed budget. Summarizing on this slide, the total budget has been used well, which gives the expected outcome come from the hypothesis. As for the conclusion from our project, we think that implementing artificial levee is important at Hulu Langat because of 4 reasons, which is the first, there were existing levees at the Langat River which collapsed due to construction of the EKVE highway. The second is the area is predominantly consisted of clay, as clay is suitable to be used to build the levee. Thirdly, the material used are significantly great to provide resistance to high pressure. And for the last, the height, the base, and the slope can be altered to give a better stability as for the artificial levee. For the conclusion, based on our explanation on our proposed levee, we believe by implementing our proposed levee, the consequences after the flash flood can be somehow reduced. Thank you.